All right, so in today's lesson, we're going to be talking about solving systems of equations still, but this time they're going to be non-linear systems. And so we could have quadratics or combinations of two different types of equations. And so let's go ahead and get started. Here we have a system that is, we have one linear equation. Here's a linear equation, but then we also have one that is a quadratic equation. So one of the things that we're going to have to remember is that whenever we have a quadratic equation, one of the first things that we're going to want to find is the vertex. And the vertex of a quadratic equation can always be found using negative b over 2a to find our x value, and then plugging that in to find the y value. And so in this particular example, notice that, well, first maybe I should do this here. It's always in this form, y equals ax squared plus bx plus c. Now it could be in a different form. This is standard form though, and most of your questions on your homework assignment will look like this. And so if we want to find the vertex of this equation, we're going to start by doing finding negative b over 2a. And so there's a 2a. And so our b value is 4, so we're going to have negative 4 over 2 times negative 1. And so 2 times negative 1 is negative 2, and if we have negative 4 over negative 2, that means our x-coordinate is going to be at the point 2. And then I'm going to plug that 2 into the equation. So if I plug it into x squared, that's 2 squared, which is 4, but then that'll give us negative 4. 4 times 2 is positive 8 minus 3. And negative 4 plus 8 minus 3 is 1. And so we have the vertex of the first equation right here at the point 2, 1. Well, once we get that point, then we can plug other points around it. We have the vertex, the center at 2, 1. We can try plugging in like 1 and 0 or 3 and 4. And if I plug in 1 here, I would take 1 squared, which is 1, and then I'd have a negative 1. So we have negative 1 plus 4 times 1 is plus 4, and then minus 3. And that gives us 0. And if we would plug in 3, we would also get the point 0. So we have 2 more points at, this is yellow, it's kind of hard to see, but we have a point at 1, 0, and 3, 0. And then if we plug in 0 to this equation, I would have 0 squared, which is 0, plus 4 times 0 is 0, minus 3. And so that would give us a negative 3. And if I were to plug in 4, I would also get a negative 3. And so that gives us 2 points here that are at negative 3, 4, negative 3, and 0, negative 3. And so if I were to graph this equation, then it would look something like this. And it does go through these specific points here. So I didn't graph it really that well. So there's the first equation. And then if I were to take the second equation and graph the second equation, the y-intercept is at 1, so that would be here. And the slope is negative 1. So I would go down 1 and over 1, down 1 and over 1, down 1 and over 1. And I have all these points here. And this line would look like this. And it looks like there's 2 points that are on both equations. And the first one would be at the point 1, 0. That would be our first solution. And the second solution would be at the point 4, negative 3. And that would be our second solution. And so the solutions, just like in solving systems of linear equations, are where the points of intersections are. Only happens here that that there are 2 intersection points. So there could be 1 intersection point if it just kind of went along like this and just barely grazed the parabola. And again, just like in solving systems of linear equations, there could be no solutions. Let's see what this would look like with a graphing calculator. So if we take our graphing calculator out, and if you have something in your graphing calculator right now, we can clear that simply, and we can clear our entire graph by resetting the memory, which would be going to second and in the memory. We would want to scroll down to reset, and so I would reset everything. I do want to reset all the defaults, and I'm going to go scroll down to number 2, reset everything. So now when I press graph, nothing is there. If I have equations in my y equals and I want to get rid of them, probably the easiest way to do that is just to highlight on the beginning of the equation and press clear. Then I could scroll down to my second one and press clear so that I don't have any equations in there. So let's go ahead and type the first equation in here. It's y equals negative x squared. So I have y equals negative, and then I need the x squared, which is the xt theta n button, squared, plus 4x, and then minus 3. And if I want to just check that and see what that looks like when it's graphed, it's a parabola that looks something like that. And that should look familiar from when we graphed this by hand. Then if I go back to the y equals, I'm going to type in my second equation on the second y equals, which is negative x plus 1. And so now I'm going to graph both of those equations. Some of you with TI-84s can even do this in different colors if you wish. But what we want to do is find where they intersect. And we found these points of intersection already when we were graphing this by hand. But this is how you would do the same thing with a calculator. You have a calculate button up here. So we're going to go to second and then trace. And then we're going to scroll down. Oops, let me do that again here. Get out of this mode. I'm going to go to second and then calculate, or second trace, and I'm going to scroll down to where it says intersect because I want to find the point of intersection and press enter. Now it's asking me if this is my first curve, but before I say yes, it is my first curve, I want to get that cursor, that little spider on the graph, to be close to this intersection point. So is this the first curve? And I'm going to click enter. And when I click enter, it's asking now, is this the second curve? So now that little spider jumped to the second curve, and it is. I'm going to get it close to the intersection point and click enter. I don't know why it says, ask me if I want to guess what the intersection point is. I really don't. I just want it to tell me what it is, so I'm going to press enter. And one solution is when x is 1, y is 0. Well, then we want to find the other intersection point. And so I'm going to do the same thing. I'm going to go to second trace. I'm going to scroll down to intersect. Except this time I want that cursor to be on the other intersection point. So right now it's on the first curve. Now it's on the second curve. I don't want to guess. I'm just going to click enter. And 4, negative 3 is our second solution for this system. So that's doing the same thing that we did by hand on a graphing calculator. Let's take a look at the second equation here that we have. And we're going to do this one with our graphing calculator. And so I'm going to go ahead and get rid of these equations. I'm going to clear them out and enter my new equations. So the first equation is x squared minus 8x, and it's important to hit the minus sign, not the negative sign. So it's minus 8x and then plus 12. And my second equation is y equals 4x minus 15. And so now when I graph these two equations, I have my parabola and I have my line. And so we are going to have to change the window a little bit because we can only see one of the intersection points. And the only way that we can get the intersect tool to work is to see the intersection point on the graph. Well, let's go ahead and do the first one right now because it is in our window. I'm going to go to second, calculate. I am going to scroll down to intersect, and I want to put my cursor close to that intersection point. So it's now on the first curve, and now it's on the second curve, and one solution is the point 3, negative 3. Then how do we get to this second solution? So I'm going to go to my window. I could zoom in or zoom out. There's different types of zooming features that also I can use in practice with the zoom menu. but I'm going to go to the window, and I need it to be a little bit longer than just 10, so I'm going to have the x values go from maybe -5 to 15. I'm going to have the y values go from -10 to, let's say, 30. I don't know how high I'm going to have to go yet. Maybe I'll make the y scale. That's every tick mark right now represents one number. I'm going to make them represent 5. Maybe I'll let the y scale be 2. And this is something you can play around with as you do your homework assignment. But now if I press graph, there's my parabola, same one, just a different window, and now I see not only the one intersection point that we already have, but I see the other intersection point. And so now I can go ahead and go to second calculate, go down to the intersection point, and move my cursor close to the second intersection point, and it is now on the first curve. And it's on the second curve. I don't want to guess. It's going to tell me that the second solution is when x is 9, y is 21. And we can plug those numbers to make sure they both, or those points into both of these equations, and we can see that they are on both the line and the parabola. So this is what we're going to be doing for our homework tonight. We will go over questions that you have on this when you get to class tomorrow.